All right, let's get right into it. We're talking about a change that's happening right now. And it's so big, it's basically like the entire internet is getting a new nervous system. And the catalyst? It's Java 26, which is set to completely rewire our digital world. So I want to start with a headline that really grabbed me. TCP is dead. Almost. I mean, that sounds pretty dramatic, right? But it points to a massive, massive shift happening right under our noses. This isn't just some small update we're talking about. It's a fundamental change to how the internet works.
And that immediately brings up a question, doesn't it? What could possibly be wrong with TCP? This is the protocol that has reliably powered the internet for decades. It's been the bedrock of our online lives, so why on earth does it suddenly need replacing?
Well, to really get it, we've got to look at TCP's hidden bottleneck. The best way to think about it is like a single lane highway. It's been incredibly reliable for years, but as the traffic has just exploded, its core design has started to show some pretty serious cracks. So TCP's whole job, its entire reason for being, is to make sure every little piece of data, every single packet gets to you in perfect sequential order. Think of it like a shipping company that's just obsessed with making sure box number 2 doesn't arrive before box number 1. But, and this is the crazy part, that very obsession with order, well, that turns out to be its biggest flaw. And that flaw has a name: head of line blocking. This is the villain of our story. So stick with that single lane highway analogy. Imagine you're in a line of cars, and the car at the very front breaks down. What happens? Yep, everybody behind it is completely stuck. And here's exactly how that internet traffic jam happens. Your browser asks for a web page. A whole stream of data packets starts coming back. But if just one of those packets gets lost or even just delayed somewhere along the way, TCP literally forces everything else to just stop and wait. The whole connection grinds to a halt until that one missing piece is found and sent again. So how do we fix this digital gridlock? Well, we move to the solution. You see where this is going, right? We replace that old single-lane road with a brand new multi-lane superhighway. And this new highway is called Quick, and it's what powers the next generation of the web, HTTP/3. The key thing to understand here is that Quick is built completely differently. Instead of one single ordered line of data, it opens up multiple independent streams. It really is like having several lanes on a highway. So if one car gets a flat tire in one lane, who cares? The traffic in all the other lanes just keeps on flowing. This comparison just makes it crystal clear. With TCP, one little error brings the whole thing down. With Quick, an error in one stream, let's say for a single unimportant image on a web page, it doesn't stop the text or the other more important images from loading. The rest of the page just keeps right on appearing. No more waiting. And when you look at them head-to-head like this, the benefits just jump out at you. First off, Quick completely eliminates head-of-line blocking. Gone. But it goes even further than that. Connections are way, way faster to set up. And security, it's not some add-on like with TCP. It's baked right into the protocol from the get-go. Let's talk about that speed difference for a second. To start a secure connection, TCP has to go through this really slow formal dance. It's this whole multi-step handshake, right? It involves several back and forth trips between your computer and the server before you can even start sending any real data. Now look at this. Look at the difference with Quick. It's so much smarter. It combines the connection and the security steps into one single action. For a totally new connection, it often just takes one round trip. And get this, for a site you visited before, it can achieve something called zero RTT. That's zero round trip time. It means the communication can start immediately. It feels practically instant. Now, this technology, Quick, it isn't brand new. Google has been pioneering it for years, actually. But we have just hit a major tipping point. And that brings us to why this is all so incredibly important, right here, right now. This isn't some theoretical, someday in the future kind of thing. No, this revolution is happening as we speak. Why? Because one of the absolute biggest players in the entire software world has just made its move. And that move is all about this number, 26. This is the version of Java that is officially bringing this new internet superhighway to literally millions of developers and applications all across the globe. Okay, and this is the moment it all becomes real. It's called JEP 485. That's the official proposal that's baking an HTTP/3 and Quick client right into the Java platform itself. Now, you got to stop and think about the scale here. We're not talking about some niche library. We're talking about Java. Millions upon millions of apps, of services, everything from your banking app to huge cloud systems run on this stuff. When a giant like Java makes a move this big, it's not an experiment anymore. That's it. It's the new standard. Okay, so we've gone through a lot of the technical stuff, but what does all of this actually mean for you, just browsing the web or using an app on your phone? Let's translate all this tech talk into the real-world experiences you're actually going to feel. A quick-powered internet just feels faster, especially on your phone or on a spotty Wi-Fi connection, because pages don't get stuck waiting for that one lost piece of data. It means smoother video streaming with way less of that dreaded buffering icon. It's a huge deal for things like Netflix or live sports. Connections are just more reliable, especially when you're moving around, and every single connection is more secure by default. Bottom line, it's just a better, faster, more responsive web for every single one of us. So here's the big takeaway. A fundamental problem with the internet, a limitation we have just lived with for decades, has finally been solved. The very foundation has been rewired for a faster, more secure future. And that leaves us with just one really exciting question. What amazing new things are we going to build with it?